Those who are not present, maybe they can listen to recording and they can understand. So basically, if you recall, we were studying chapter 1 in last lecture. I hope all of you have downloaded the CLOs of this course, so you have now idea that what we are going to study in the class, right? Uh, Let me share the slides of the lecture and then we'll start. Right, a number of students are not present right now. So, anyways, let's start. Okay, can you see the slides?
Yes, sir.
Okay, that's fine. So, if you recall that last lecture, we studied, we started with chapter 1, and basically we studied about what is internet, what is protocol, and what is network edge. And these are the details which we studied. So I hope you now have idea about architecture of internet, definition of protocol, and network edge, media, various type of media like guided media, unguided media, copper, optics, etc. So now today we are going to start network core. Uh, so let's start. Now, if you look at the right side, this is slide number 3, right? If you look at this bottom, you can see here 1, 3, slide number 3. Okay, so if by any ways, if you are not able to, see the slides, then CR is requested. Please WhatsApp me, message me so that I can do the corrective action. Okay, Ji. So if you look at this thing, right side, so this is the same diagram which we are studying from last class. So we have, networks, different networks, and we have hosts or end systems. And if you recall, last lecture we have studied about end systems and physical media and different kind of networks. Now, today we're going to study about network core, that what is located inside the core. So if you look at this encircled, red encircled area, this is, basically comprises of network core. And what is inside it? Basically, we are having a mesh of interconnected routers. We have a lot of interconnected routers. Naturally, they are connected generally by high bandwidth fiber optics uh, or optical fiber, and the prime component in it is routers. So you see here that there are, various types, various number of routers. Now, here in network core, we are only showing you two components. One is known as local or regional ISP, and the other one is described as national or global ISP. But keep this thing in mind that practically we have hundreds of these ISPs, or in fact, thousands of ISPs of various categories. So, and each ISP is managing a part of this mesh of connected routers, you can think like that. And if you recall that we said that when data is transmitted from host, it is divided into, actually bits are generated. You know that bits are generated, and we call them as chunk of bits or chunk of data. And chunk of data is known as, the typical standard name for it is, क्या कहते हैं उसे, chunk of data को कोई बताएगा? The packet. So we are calling it as packet. So what happens that if you recall, last lecture, that host is the end system, like a laptop, like a smartphone or any other device. So basically it breaks the application layer. There is a layer. We'll talk about this layering structure, but you can consider it as a module. For a meanwhile, consider it as a module because we didn't study layers things. Later on in this chapter we'll study it, but call it as a module for simply for right now, because layering is something which I will explain it to you at in the end of this chapter. Okay, so application layer or message basically is generated from application layer or application module, and that message is basically broken into packets, right? So here, if you look at my mouse, so let's say this is a laptop. Laptop's application module generated packets, right? And these packets are transmitted through this network. It's home network, mobile network to the core. And now when it arrives at core, basically, or in fact, when it is received by routers, so the job of router is to forward the packet from one to another. How? What is the objective? So that it can reach to the destination, right? So naturally, this laptop on the top left basically wants to send data to some other, host in this network, in this internet. So the job of router is to forward packets from one router to another router so that it can reaches the destination. This is an important thing, and this is a job of router that it will look into the next route. For instance, look at this. This laptop has given to this mobile network, this base station, and then this is the first router, and then this is a router, this global ISP. And now from this router, it has to make a decision. During this, it has to make a decision because it has how many paths? It has three links, one, two, three. We also call them as interfaces, and we also call them as interfaces or ports. Sometimes we also call them as ports. So this router has three interfaces, let's say. So from one is from where it is coming, in a packet is coming. So we'll leave it. Now it has to take a decision that this interface should be used or this interface should be used. This is a decision which is taken by a router. I mean, and basically it will make a decision that which interface should I use so that incoming packet reaches the destination. So this is an important thing, job of a router, and core device in your core network is basically a router. And then each packet is transmitted at full link capacity because they are connected to link, and direct links are there. So each packet is transmitted whatever the link capacity is. Full capacity is used to transmit the whole packet. Right? Have a look on it, and if you have any question, you are welcome to ask.
ये फुल लिंक कैपेसिटी क्या होती है?
Beta, sometimes what happens that this link capacity is divided into channels, right? If you recall, जो within a local area network है, if you recall, हम जब पढ़ रहे थे local area network तो हमने कहा कि bandwidth जो है वो divide हो जाती है channels में, virtual channels में, ठीक है? Portion of
Yes,
the,
sir.
and each node is allocated a part of that bandwidth. So that is not known as link capacity. Full link capacity का मतलब है कि तमाम की तमाम bandwidth source को दे दी जाए. So this is what we call full link capacity. Okay, that capacity, that link capacity is not shared by any other, device or any other transmission, and all of that capacity will be used to transmit the packet, each packet.
सही होगा सर, ठीक.
Okay. Okay, Ji, if you don't have any question, let's move to the next slide. So this is slide number 4. I'll wait a little while so that you can see the slide. Okay, Ji. I hope you have seen the slide. So this is a store and forward concept. Now we are going to go into further details of this network packet switching. And if you look at the diagram, this top diagram, I am at slide number 4, and you see here that left side is having a keyboard or system. Call it as a source. Let's call it as a source. And right side is having a destination. Now for simplicity, we have taken a one device between it, one router between it. That this left side source is connected to right side destination through one router. Practically speaking, we have set of routers between source and destination. If you recall last slide, you have seen that mesh of routers is there, but for simplicity, just to demonstrate the concept, I am using only one router. So, but that concept, if you understand this concept, that can be extended to multiple routers also. So, if you recall, we have L packets, L bits per packets, and the link uh, capacity is R bits per second. So recall transmission delay. If you recall, in last lecture we studied transmission delay, that it takes L by R seconds to transmit push out bits L bit packets into R, right, at RBPS. So this is important to understand. What does it mean? So L bit packet. So let me tell you, once I say L can be any number of packets. L can be 1000 bits, 2000 bits, and R is a capacity of a link, right? R is the capacity of link. So when I say that it takes L by R seconds to push out L bit packet into a complete packet, let's say L is 1000 bits, so 1000 bits, complete 1000 bits will be transmitted in L by R time. So this is an important thing which you need to understand, right? So this is what we call transmission delay. This is something which we have already studied in the last class too. So, for example, if I one hop, if you look at this, there is a hop. Hop is maybe a new term for you. So let me define the hop. Hop is the distance between two interconnected devices. Two connected devices, directly connected devices. Device can be a router, can be a switch, can be anything. So directly connected devices, distance between two directly connected devices is known as one hop.
Oh,
This is unitless. This is the unit of, there is no unit of hop. Uh, Physically, if let's say this L packet, this is a, just source, and this is a router. So distance between source and router is how much? What is the distance in terms of hop? Can anyone tell? Am I audible to everyone?
जी सर, you are audible.
Yes, so to
So
get
I
the
told you that distance between two directly connected devices is known as one hop. So are these source and router is directly connected to each other?
yes sir, one hop distance होगा.
So it's a one hop distance, right? And from this router to right side destination, how much distance? Router to destination?
two of destination.
Router to destination. I am talking about router to destination. This is
One hour.
one
One
hop.
of
And now if you calculate total from source to destination, 1 plus 1, 2 hops,
two.
right? Now this distance can be 100 meter, 1000 meter, 1 kilometer. Still, it will remain one hop. It is independent of geographical distance. The only requirement is that they should be directly connected to each other, right? So keep this definition in your mind. Okay. So look at
सर आप
this.
कह रहे हैं कि
G. जी
डायरेक्टली
please.
कनेक्टेड होना चाहिए, तो अगर ये जिस तरह हम शुरू से सोर्स से डेस्टिनेशन तक ले रहे हैं, तो ये आपस में डायरेक्टली कनेक्टेड तो नहीं है, इनके दरमियान तो राउटर आ रहा है। हम इसको किस तरह
इसलिए
टू
मैंने
हॉप्स
वन
बोलेंगे?
हॉप की डेफिनेशन बताई ना बेटा, वन
जी,
हॉप की डेफिनेशन बताई है मैंने। डायरेक्टली कनेक्टेड होने के लिए होगा तो आप उसे वन हॉप कहेंगे ना।
मतलब सर हम ये सोर्स से डेस्टिनेशन तक टू हॉप्स तो नहीं ले सकते,
क्यों? सोर्स
क्योंकि
डेस्टिनेशन
ये
डायरेक्टली कनेक्टेड है।
सर इनके दरमियान राउटर
हाँ तो
थोड़ा।
मैंने कहा सोर्स से राउटर तक वन हॉप और राउटर से डेस्टिनेशन वन हॉप,
यस,
तो टोटल करें 1 + 1।
वो तो सर समझ आ रही है कि टू हॉप्स हो जाएंगे,
हाँ तो
लेकिन हम इस तरह ले सकते हैं कि सोर्स से डेस्टिनेशन तक टू हॉप्स हैं, क्योंकि अगर जिस तरह आप कह रहे हैं कि
वन
ये
हॉप की
आपस में पैरेलल।
डेफिनेशन देखो, हॉप की डेफिनेशन जो है ना, वन हॉप की या हॉप की डेफिनेशन यही है कि जो डिस्टेंस बिटवीन टू इंटरकनेक्टेड डायरेक्टली इज वन हॉप। तो टोटल जो है वो जितने दरमियान में डिवाइसेस आएंगे उतने हॉप्स एड अप होते जाएंगे ना,
ठीक है सर।
राइट?
यस,
ओके, नाउ so what is the delay? If you look at this, L is 10 kilobits, say suppose 10 kilobits, L is 10 kilobits and R is 100 Mbps. So one hop transmission delay is about zero point 0.1 millisecond. 0.1 millisecond. So L by R, correct? Now, what is store and forward concept? What is store and forward concept? Uh, Entire packet. Now, this is a quite important concept which is used in packet switching. That entire packet must arrive at this router before it can be transmitted onto the next link. एंटायर पैकेट मस्ट अराइव। एंटायर पैकेट से मुराद ये है कि लेट से आपकी 10 किलो बिट्स हैं, 10,000 बिट्स हैं, तो तमाम की तमाम 10,000 बिट्स मस्ट अराइव एट द राउटर बिफोर इट कैन बी ट्रांसमिटेड टू द नेक्स्ट लिंक। इट डज नॉट हैपन लाइक दिस कि जी फर्स्ट बिट आ गई तो फर्स्ट बिट, नेचुरली बिट्स आर ट्रांसमिटेड सीरियली, right? From this source bits are transmitted 10,000 bits, bit 1, bit 2, bit 3, bit 4 and so on up to 10,000 bits will be transmitted onto the link. So it will be transmitted serially. So it will take L by R to transmit time, right? L by R is there. So now this router naturally will receive first bit because it is transmitted at the beginning. So first bit it will arrive at earlier and then next bit and so on. Eventually it will get 10,000 bits. So the rule is this in store and forward that it must wait for all the bits to arrive at this router before it can transmit to the next link, right? And this phenomena is known as store and forward. We call this phenomena as store and forward. Okay, Ji, is it okay? Any query about store and forward concept?
No, sir.
Okay, so this is a concept which is used in packet switching that every router must receive all the complete packet before it should transmit onto the next link. Now, if you look at the delay, total delay, recall that L by R delay is onto this link. So what would be the total delay from source to destination?
0.2 milliseconds.
0.2, or mathematically, if we assume propagation delay is zero, if we assume for the time being, so L by R for this, L by R for this, so it would be 2L by R. So we'll talk about delays shortly, but for the meanwhile, you can say that 0.2 millisecond or 2L by R, right? So there will be a transmission delay would be 2L by R. Okay, have a look on it, and I'll give you 1 minute to review what we have studied in this slide. And if you have any question, then you can ask. Okay, Ji, is it okay to everyone?
Yes, sir.
Okay. Now let's talk about a little bit about delays. As you have seen in that last slide, I have said that we'll be talking about these delays, you know, soon. So let's have a look on further about packet queuing first of all, and then we'll talk about delays also. Now, naturally, if you look at this diagram, you see here that there are four nodes or systems or hosts, whatever you call them as A, B, C, D, and E. And there are three routers in this network, call them as network. Now, naturally, this router, if you look at this left router, it is connected to two hosts, A and B. Now, the point here is that A and B can transmit at any time they want. There is no prior kind of permission or something like that in packet switching. If they want to, A and B want to transmit at any time, they can transmit. Suppose that A or B are transmitting to this router. Now, if arrival rate means in terms of bits per second, exceeds the link transmission rate. This is the transmission rate, right? For instance, R is 100 Mbps here. Here is 100 Mbps and here is R is 1.5 Mbps, right? Right? I hope now you can understand this, that this is R for, transmission rate. Here it is transmitted right side. The left side say arrival R. Now, if arrival rate is the transmission rate, naturally, what will happen? First of all, packets will queue in this router because the rate is much higher. For instance, if you look at this rate is, let's say rate is 100 Mbps and here transmission rate is 1.5 Mbps. So naturally, what will happen? That packet will not be transmitted at the same speed as of arrival rate. So there will be a queue of packets. There will a queue will be generated in this router. There will be a queue of packets waiting for output link because output link transmission is slower than the arrival rate. So queue will be generated at the for a output link. Queue will be generated. Queue of packets will be there waited to be transmitted on output link. Naturally, this queue, what is this queue? This queue you can think like queue as a buffer. There will be a buffer and all the packets will be stored in the buffer. Meanwhile, they are being transmitted. Now, naturally, you know that buffer has a limited capacity. Buffer cannot be of infinite size practically. So, if arrival rate continuously, coming packets are continuously coming, then buffer will fill. Buffer will fill, and if buffer becomes fills up, then there will be a packet loss, or packets will be dropped, and we call it as packet loss. So this can happen at any route. So this is what we call queuing. So naturally there will be a delay due to queuing, and then there will be a packet loss. So these are the two phenomena which frequently occur in routers if their buffer fills up. Have a look on it, and if you have any question, you are welcome.
सर तो फिर हम ये कहेंगे कि भाई इनकी स्पीड ट्रांसमिशन की और अराइवल की हमारी सेम होनी चाहिए सर अगर सेम होगी
जी जी प्लीज गो अहेड फॉर विद योर क्वेश्चन, फिर मैं आपको आंसर करता हूँ। आप क्वेश्चन
सर जी सर अगर स्लो होगी रेट तो फिर ही हम लोग के पैकेट्स पूरे एक दफ़ा स्टोर होंगे और फिर आगे ट्रांसफ़र होंगे अगर कम होगी तो फिर ही ऐसा होगा ना पॉसिबल अगर ज़्यादा होगी तो फिर तो स्टोर नहीं होंगे कंप्लीटली और आगे ट्रांसफ़र होते जाएंगे।
देखें स्टोर, देखें पैकेट, पूरे का पूरा पैकेट, एक तो जो स्टोर एंड फॉरवर्ड, दोनों को मिक्स मत कीजिएगा प्लीज। स्टोर एंड फॉरवर्ड जो कॉन्सेप्ट आपने लास्ट स्लाइड में पढ़ा है वो तो हर सूरत में रहेगा, पूरे का पूरा जब तक पैकेट नहीं आएगा, सिंगल पैकेट की बात कर रहा हूँ, तो पूरे
जी
का
सर।
पूरा पैकेट जब तक राउटर पे नहीं आएगा, राउटर से आउटपुट लिंक पे नहीं भेजेगा। एक चीज तो ध्यान में रखें। अब डिफरेंट पैकेट्स के बारे में आप ये कह सकते हैं कि अगर डिफरेंट पैकेट्स जो है, अगर आप चाहते हैं क्यू में ना आए, तो फिर तो अराइवल रेट और जो आपका ट्रांसमिशन रेट है सेम हो, तो फिर क्यू नहीं जनरेट होगी, ऐसे ही है ना।
जी सर।
बट प्रैक्टिकली स्पीकिंग यू हैव हंड्रेड्स ऑफ राउटर्स, you have 100 of routers, and each router does not have same rate as of arrival. सेकंड चीज ये है कि ए और बी की जो ट्रांसमिशन अराइवल है ए और बी से, दैट इज बर्स्टी इन नेचर। ए एंड बी विल नॉट बी ट्रांसमिटिंग एट द सेम टाइम always. A can be, like internet, I mean, it's not logically that all the people in the world are using internet at the same time,
यस सर।
right? So we cannot predict the arrival rate, and bursty in nature sometimes, say for arrival packets are coming from A, sometimes are not coming from A. So naturally there will be queuing. Queuing can happen, right? Queuing can happen. It's a natural phenomena. Queuing lazmi hoti hai. And second thing is you cannot predict कि A और B से packet at the same time आएंगे. Prediction is not easy, right? But ideally, if you say, so ideally, yes, you are right, that if arrival rate and transmission rate becomes same, then there will be no queuing. But practically, queuing occurs.
ओके सर।
Okay, ji, anyone else? Okay, so let's, if you don't have any question, let's move to the next slide. Now, more details coming. So look at this mesh of routers. Now we are going to study another thing, which is known as network core functions. Two network core functions, two main core functions. Now here you see a diagram. Have a look on this diagram. There is a mesh of routers. There is a mesh of routers, and they are connected. And then each router is having this table. We call it as table. This thing, this table, and elaborated table is shown for this router, top left router, right? And now I'll explain it to you. Just have a look on this diagram, and then I'll explain it to you gradually. So look at this one. How many routers? 1, 2, 3, 4, 5, 6 router. Each router is having a this table, kind of table, and we basically in fact you know use this table for forwarding. Now let me explain this. So look at this. We call this as forwarding table. This table is known as this table which you are seeing. Look at this red color. Local forwarding table. Why we call it local? Local means that this table is present in within a router. This basically table is present within a router. So that's why we call it as local forwarding table. Generally, we call it as forwarding table. Generally, we will be calling it as forwarding table. And because this table is present, each router is having a table is present inside the router, we call it as local forwarding table. Now you may be wondering that there may be a other side. We will talk about it later on in chapter 4. So local action will be taken. Now what is the local action? Local action means that, let's say that, look at this leftmost router. Let's say that the packet is coming. Now each packet will be having a, naturally that one packet, the objective is to send the packet from source to destination. The objective is to send the packet from source to destination. So each packet will be having fields. For simplicity, there are many fields in each packet, but for just your understanding that each packet will be having one field which is known as destination address. We call this as destination address, and there will also be a source address from where source address will indicate that from where packet is coming, and destination address is the address of the destination where packet should be sent, right? So here you see here that only source address is not shown here, destination address is shown here. This is a 4-bit destination address 0111. Practically speaking, we have 32-bit or 128-bit address, but for simplicity we have taken here only 4 bits. We have taken here only 4 bits. So let's say that the packet has come from somewhere from left side and it is having a destination address. Now when this packet will arrive at this router, so router will consult its local forwarding table. When this packet will arrive at router, router will consult, I will simply call it as forwarding table, it's a local forwarding table, but router will consult its routing forwarding table and will match arriving packets address, destination address with its table address. So look at this table that it says that if destination is 0110100, the output link to be used is 3. So these are output links 1, 2, 3. And if destination address is 0101, output link should be 2. And if destination is 0111, output link should be also 2. And if destination is 1001, output link should be 1. So what will happen that basically this arriving packet's destination address will be matched, will be looked up into this table. Lookup will be performed, and which row will match with this destination address? कौन सी row destination address से match कर जाएगी?
3 वाली सर।
Link
Row
to
3. Row 3. So which link will be used for this packet?
link.
नंबर
Link
2
2 will be used. So this packet will be transferred to link 2, right? So this is a just a simplified phenomena which occurs at every router for every packet independently. Every packet will be having a destination address, and in this way this lookup will be performed, and this kind of action, we call it as local action will be moving packet from router's output link input link to the appropriate router output link, and this will be done with the help of lookup. So local action would be, what is local action? That move the arriving packet from router's input link to the appropriate router's output link. There are 3 choices, 1, 2, 3, and this will happen with the help of a forwarding table. Right, G? Then, uh, okay, before I move to, global phenomena, so just I'll wait here, and if you have any question, then you can ask. Is it okay to everyone, G?
सर ये जो हेडर वैल्यूज हैं ये हमारे पास किस तरह आती हैं? खुद हम
ये
अज्यूम
जब
करते हैं।
देखिए ये एक you will study in detail in this course, but for simplicity you can learn this that when you know uh, packet is generated at the source, packet is generated at the source, ठीक है, that values will be added in the header, ठीक है।
यस
ये कैसे आती हैं? It's a long story. I'll explain it to you in a chapter 4. Assume that somehow it source gets it,
ठीक
but
है सर।
source will add these values of destination. For instance, if as a human being, if I don't know where I want to go, then how I can decide on which road should I move, huh?
यस सर ठीक।
So for simplicity, assume by somehow source knows it, because it takes a complete chapter to explain this. So you will study it in chapter 4 probably.
ठीक है सर।
Okay, okay, Ji, is it okay? So this is what we call local forwarding, local action, local forwarding table. Now let's move to another thing. Oh, where it is, where was? Okay. Now there is a global action. Global action means that determine the source to destination paths taken by packets. Now, global action, what is this? Is a local action, right? This local action means that consult the forwarding table and compare the this address with the incoming address, table's address, incoming address with the table address, and find out the output link. Global action means that the question comes in. No one asked me from me that from where this table comes in. जो ज्यादा जो राउटर पर्सपेक्टिव में कि टेबल कहाँ से आते हैं, ये टेबल कहाँ से आते हैं, तो द आंसर टू इट इज ग्लोबल एक्शन. So global action means there is a routing algorithm. Look at this routing algorithm. This routing algorithm is the basically key component in routers, and it basically determines the source to destination paths taken by packet. Means the forwarding table are computed by the packets. Sorry, routing algorithm. So global action means routing algorithm, and this routing, the job of routing algorithm is to determine the source to destination path. Look at this header value. This is a, let's say, output link. That if this is a destination, this is the output link. So the job of routing algorithm is to determine the source to path destinations taken by packets, and they are then placed in forwarding tables, right? So this is what happens, and this is a quite a hectic job, and it takes a lot of processing. So we'll study, more details in chapter 4, but this is a global action, right? Global action is known as routing, and this is done with the help of a global action is done with the help of a routing algorithms, right? And what is a global action? Determine the source to destination paths taken by packets. It will determine it, and then it will populate the forwarding tables, and these forwarding tables will be used for local action. Local action means moving the arriving packet from router's input link to the appropriate output link. Okay, Ji. Have a look on it. Is it okay to everyone, Ji?
Yes, sir.
Okay. Now let's move to another way. So far we have studied about packet switching, right? We have studied packet switching. In packet switching, I told you that basically, if any source wants to send a data, it can send data with its own will without consulting the destination. So anytime any source wants to send data can send the data, right, in packet switching. Now there is an alternative to packet switching, and this is known as circuit switching. We call it as circuit switching. Now what is circuit switching? So let me give you analogy for circuit switching. It's like a telephone network. Circuit switching like is a telephone call. And in a telephone call, what do? You basically first I mean, if you want to talk with someone, you don't start talking. First, you need to dial a number, right? And then once connection is established between you and your friend, then you start talking. So this establishment of connection is a requirement before you talk in telephone, right? And during this connection establishment, actually what is happening that basically the resources are reserved, whether that connection is available in the exchange or not, where circuit is available in the exchange or not. So this is basically being checked. So therefore, you can think like this, that resources are reserved during the call. In circuit switching, end to end, when you establish a connection between source and destination, the benefit is this, that you can reserve the resources needed or for that call between source and destination. For example, you can reserve the bandwidth requirement. I need minimum, let's say, of a certain bandwidth. So this is something which happens in circuit switching, that basically you need to establish a connection, and during that connection establishment, end-to-end resources are allocated to or reserved for a call from source to destination. So if you look at this diagram, so you see here that again there is a network of 4 routers, and there are different hosts. So here, host, top left host is connection is established with bottom right host. Now here basically what you are seeing here, that there are four connections, right? One connection is established. This is having a four circuits. One, so these each row is having a one circuit. So there are four circuits. So you can say that call gets second circuit in the top link and the first circuit in the right link. Now the benefit is this, that connection is established. You need to establish a connection before sending a data. Now the benefit is this, that you can reserve the resources. You can reserve the resources, and there is no sharing of bandwidth. In case of, if you recall, in case of packet switching, if more users comes in, then packet bandwidth is shared. The bandwidth of a link is shared, in fact. But in this case of circuit switching, there is no sharing. So if there is no sharing, if you have a dedicated part, this means that you have a guaranteed performance. Guaranteed performance, right? Now this is a plus point of circuit switching. And but there are some things which are there, downside, or you can say that. For example, this top left system will not be sending 24 hours a day a data. So if you have reserved a connection for it, so if there is an idle period means that no data is transmitted from top left to bottom right, that will not be used by any other call. That will remain idle. That will remain idle because there is no sharing. So that bandwidth would be wasted. That channel time, or the time at which this top left is not sending any data to this, because this connection is reserved for them. So it will remain idle. So this is something which is there. So commonly used this method is circuit switching is telephone networks. This is commonly used, and this is what we call circuit switching. Have a look on it, and if you have any question, you are welcome.
सर ये स्लाइड में लिखा हुआ है कॉमनली यूज्ड इन टेलीफोनिक नेटवर्क्स,
जी
तो हमारे जो टेलीफोन्स होते हैं उनमें सर्किट स्विचिंग हो रही होती है, मतलब कॉल के दौरान?
नहीं, कॉल के दौरान नहीं। कॉल, जब आप कॉल एस्टेब्लिश करते हैं तो आपके लिए एक डेडिकेटेड चैनल रिजर्व किया जाता है, राइट?
सो सर मतलब एक टाइम पे अगर काफ़ी ज़्यादा यूज़र्स कॉल कर रहे हो तो वो मुश्किल नहीं हो जाती इतने ज़्यादा चैनल्स को रिजर्व करना फॉर
बेटा,
ईच
एक्सचेंज
यूज़र?
के अंदर थाउजेंड्स ऑफ स्विचेस होते हैं। एक्सचेंज के अंदर थाउजेंड्स ऑफ स्विचेस होते हैं। लेकिन लेट्स से एक एक्सचेंज के अंदर 1000 स्विचेस हैं, तो आपके 1000 कनेक्शंस एट ए टाइम इस्टेब्लिश हो सकते हैं, ठीक है। लेकिन सपोज करें कि इफ यू हैव 1001 users at the same time,
जी सर।
so what will happen? 1000, because there are only 1000 connections, so the additional, the person will not get the connection, it will may get a busy tone, that
सही
connection is
होगा
not available.
सही
So
होगा।
assumption is this, बहुत सारे users के they will not be talking at the same time. So it's not like this that 1 million people are talking, so 1 million connections will be there. They assume that a certain number of people will be talking at the same time.
सही होगा सर, सही होगा।
और अगर यूजर्स बढ़ जाते हैं, इट इज पॉसिबल दैट users increase, number of users increase the number of available circuits, then they will not be able to establish a call additional user until unless some other user becomes free.
सही होगा
Okay,
सर। यस सर।
so now you have studied circuit switching and packet switching. In packet switching, now recall packet switching. Packet switching means you are not required to establish a connection, you can send data at packet at any time you want, but you will be sharing the link capacity. Okay. Now there are two methods for circuit switching. I assume that this is something which you already know about it. FDM and TDM. Am I right? Did you
जी
study
सर,
in
पढ़ा
जी
है।
the?
सर।
Okay, I'll briefly go through this. So this is this, that in FDM, the frequency is divided, available electromagnetic frequency is divided into narrow frequency bands. Let's say here for 4 users, 4 bands are there, and each call will be allocated its own band, can transmit at a maximum rate of that narrow band. Right? This is known as FDM. Frequency is divided. Look at this animation. 4 users, so 4 different bands, dedicated bands. In TDM, time slots, time is divided into slots, right? And each call periodically gets slots and can transmit at a maximum rate of that frequency band. Now frequency is same. In TDM, frequency is same, right? And time, different time slots पर different channels transmit, source transmit हो रहते हैं. FDM में time is same but frequency bands are different. So this is our difference between TDM and FDM, right? Look at this. Different time slots. Okay, Ji, is it okay to everyone? I assume it's okay to everyone. But again, still, if you want to ask any question, you are welcome. Okay, because I assume that you have already studied about it, so I'll move to next slide. Now there is an example, numerical example. So how long it takes to send a 640,000 bits from host A to host B over a circuit switch networks. All links are 1.536 Mbps, and each link is using TDM with 24 slots per second. And then we have a 500 millisecond to establish end-to-end circuit. So think about it. I'll give you 2-3 minutes, and then otherwise I'll show you the answer. We'll discuss the answer, but first try yourself by taking 2-3 minutes. How you can do that? Okay, Ji, is it okay? Anyone having any proposals for solution of this?
सर इसमें हर एक लिंक 1.536 मेगाबिट पर सेकंड ले रहा है ना, और हम लोगों ने 8 सेकंड को 24 डिफरेंट पार्ट्स में डिवाइड कर दिया है, तो 1.536 को 24 पे डिवाइड कर देंगे, वो हमारे पास आर डिसाइड हो जाएगा। फिर वो एल बाई आर वाले फार्मूला था, तो हम 640,000 को उस जो जवाब आएगा उस पर डिवाइड कर देंगे।
Okay.
और सर क्योंकि इसमें वो प्रोपेगेशन डिले भी है ना, तो वो भी फिर जो भी जवाब आएगा उसमें ये भी ऐड कर देंगे, क्योंकि जो रास्ते में प्रोपेगेशन डिले ऐड होता है।
Okay, end-to-end circuit. This is not
जी
propagation delay. This is time to establish a circuit, right? Because in circuit switching, you first need to establish a connection. So
ओके
we just want to make elaborate this thing that it will take additional time to establish a circuit. It will take additional time to establish a circuit. Okay. So this is what we have possible solution. Like mentioned, that bandwidth is divided into 24. So 1.5 to 24, slots per channel. So 1.536 divided by 24, so it will be 64 kilobits per second. So then L by R, L is 640,000 bits and R is 64 kilobits. So it will be 10 seconds to transmit file. Okay? So 10 seconds, and this 500 millisecond also you will add it. 500 millisecond means 0.5 second. So 10 plus 0.5 seconds. So it would take 10.5 seconds to send a file. Right? So because this transmission time will be independent upon the number of links. Propagation delay, we are not assuming. Propagation delay will definitely there. Okay, जी. Is it okay? We have a look on it. किसी को question पूछना है तो पूछें.
ये 1.536 जो है ये डिवाइड हो रहा है 24 पे।
बेटा ऊंचा बोलें.
सर ये जो 1.536 है mbps ये
जी.
डिवाइड हो रहा है 24 पे।
जाहिर है अब डिवाइड हो रहा है ना. देखें यहाँ पे पीछे क्वेश्चन में देखें तो आपके 24 स्लॉट्स हैं ना पर सेकंड. टीडीएम
जी
यूज
जी
कर रहा है ना, टाइम डिवीजन मल्टीप्लेक्सिंग,
यस सर
तो इसलिए 24 से डिवाइड हो रहा है.
ठीक हो गया। और उसको 64 किलो बिट्स
आंसर आ जाएगा 64 किलो. तो हर जो स्लॉट का जो बैंडविड्थ होगी वो 64 किलो बिट्स पर सेकंड होगी. फिर एल बाय आर,
जी सर एल बाय आर
तो आर इज
ठीक हो गया
64
जी सर
और 0.5 की कनेक्शन एस्टेब्लिशमेंट के लिए 500 मिली सेकेंड है तो वो ऐड कर रहे हैं.
ठीक हो गया
ओके जी. सो लेट्स मूव टू द next thing. Now we want to basically compare packet switching with circuit switching. So in order to demonstrate this, we'll use this slide. Now recall that in circuit switching you establish a connection and number of allocation channel must be available, right? If you want to transmit, if there is no channel then you cannot transmit. Okay, so it means that you need to reserve resources in advance. But in packet switching, what happens that we'll talk about it. Let's take an example. Say we have this link 1 Gbps link, and here in this router we have n users. Now again there are n users, but you know that n users will not be active at the all the time. We are saying this thing, and it's practically feasible thing and practically logical thing, understandable thing, that n users will not be active at the same time. Now we are assuming something, and we are assuming that each user will be active 10% of the time, and then it will getting 100 mbps when active, 100 mbps when active, 100 mbps when active, right? Because bandwidth is shared, bandwidth is shared. Now example is this is a scenario example. Now in what will happen if you multiply 100 with how many users, that you get 1 GB. अगर आप
10
100
यूजर
mbps को कितने यूजर से मल्टीप्लाई करें तो आपको 1 GB मिलेगी? तो आंसर इज 10 यूजर्स। ऐसे ही है ना?
जी सर
100 multiplied by 10, 1000 mbps or 1 gbps. So in circuit switching 10 users can be used at the same time. Is it right? In circuit switching you can use 10 users at the same time, not more than 10. But in packet switching there is no restriction on number of users. There is no restriction of number of users. So let's assume that we are having 35 users. With 35 users, probability is greater than 10 active user, that is same time is less than 0.004. Probability that if you are having a 35 users, total 35 users I am talking, probability is this, 10 active user at the same time is less than 0.004. Are you following my point? That because in packet switching there is no restriction on number of users. So naturally, if you are having a 100 mbps when a user is active, so probability is this, and naturally you can 10 active users can use 100 mbps at the same time. So the probability that more than 10 will become active is less than 0.004. Are you following my point? So it means that the
यस
benefit is this, that in packet switching can allows more users to use the network. We'll talk about these questions later on, but just meanwhile you understand this thing.
सर फिर सर्किट स्विचिंग में क्यूइंग वाला फिनोमेना नहीं होगा क्योंकि वो तो अलाउ ही नहीं कर रहा ज्यादा यूजर्स को।
सर्किट स्विचिंग में क्यूइंग नहीं होती, बिल्कुल यू आर राइट। सर्किट स्विचिंग हैज इट्स ओन बेनिफिट्स।
ओके
सर्किट स्विचिंग देखिए मैं आई एम जस्ट वांट टू एलैबोरेट दिस थिंग दैट you cannot say that one method is poor and other is best. Each method has its own pros and cons. Okay, so if you look at this, so you can see here, okay, each method has its own benefits and advantages and disadvantages. In circuit switching, the benefit is this, that you can reserve the resources and there will be no queuing, and there are guaranteed, service. but the restriction is on number of users. But in packet switching, naturally, more users can comes into play, but the disadvantage is that there can be queuing. If more users comes in, if for example, if there are more than 35 users, so what will happen? There may be queuing, right? If greater than 35 users, there may be packet loss. So many things can happen. Right, Ji?
Yes, sir.
Okay. Now the comparison of packet switching versus circuit switching. Now, if there is a bursty data, do you understand what is bursty data? जी, किसी को पता है bursty data क्या होता है?
सर वो थोड़ी देर के लिए बहुत ज़्यादा डाटा ट्रांसफ़र हो।
Bursty data means that no, burst means that there is no pattern of transmission of data. यानी you know, one thing is periodic. कि you predict और एक regular pattern में data transmit हो रहा है. So when we say bursty data means there is no pattern of data. Sometimes it has data to send, sometimes it has no data to send. Right? So this method of packet switching is great for such kind of bursty data. Because benefits are like this, that resource sharing is done, and simpler because there is no call setup. There are no reservation of resources, so it's simpler. But disadvantage is this, that congestion is possible. Excessive congestion is possible. There may be packet delay and loss due to buffer overflow. Recall this. So therefore, additional protocols are needed to have a reliable data transfer congestion protocol. So we'll study these reliable data transfer methods. So this is what we have, plus of packet switching and disadvantage of packet switching. Now the people are working to have a behavior. Let me tell you, by the way, that today's internet is packet switch network. Predominantly, it is a packet switch network. Today's internet is predominantly packet switch network. So how to provide a circuit like behavior? So then you need a bandwidth guarantees for video and audio applications. So I know. Let's skip these analogies. You can think of analogies of human analogies of reserved resources, circuit switching versus on-demand allocation. There may be many analogies. Okay, ji, have a look on it. If you have any question, you are welcome.
सर आपने कहा ना कि पैकेट स्विचिंग में पैकेट लॉस भी हो सकता है, तो जब 10 से ज़्यादा यूज़र्स यूज़ कर रहे होंगे एट द सेम टाइम, तो फिर वो 100 MB जो 100 MB पर सेकंड के बजाय उससे कम भी डाटा उनके पास जा सकता है या पूरा ही जाएगा?
देखिए, अगर आप कह रहे हैं कि जी हर कोई 100 MB पे ट्रांसमिट कर रहा है, हर कोई 100 MB पे ट्रांसमिट कर रहा है ना, तो क्या होगा कि अब आपका वो जिस तरह मैंने आपको बताया था कि क्यूइंग डेवलप होगी, ठीक है, क्यूइंग डेवलप होगी, क्यू होगी राउटर के अंदर, और क्यू की एक लिमिटेड है। अगर बहुत ज़्यादा यूज़र्स सब जो है वो ट्रांसमिट करना शुरू कर दें तो क्यू बफर जो है, बफर आपका फिलअप होना शुरू हो जाएगा और इवेंचुअली यू नो आपका पैकेट लॉस होना शुरू हो जाएंगे।
सर इसलिए जब हम नेट यूज़ कर रहे होते हैं तो ज़्यादातर जब पैकेजेस ज़्यादातर हम यूज़ कर रहे होते हैं तो पैकेट लॉस होते हैं।
जी, पैकेट लॉस होता है, फिर आप रिफ्रेश करते हैं, क्योंकि ये बेसिकली ये होता है कि ये बड़ा रैंडम बिहेवियर है, तो इसलिए आपका एडिशनल अल्टरनेट पाथ्स भी मिल सकते हैं राउटर को, ठीक है, राउटर डिफरेंट राउटर भी यूज हो सकता है, तो बिल्कुल ठीक है।
ठीक है सर।
ओके जी, so let's have a look on this. Maybe we didn't talk about statistical switching multiplexing. I'll explain it to you in this question, and I'll not ask you to answer this question. So there is one concept of statistical multiplexing. Recall that you have studied time division multiplexing and FDM, right? Now let me explain that through this review question, that what is statistical multiplexing. Uh, Basically, the statistical multiplexing means that if you recall time division multiplexing, that each host gets the same slot involving TDM frame. Okay, each host gets the same slot in TDM. But in statistical multiplexing, packets from different sources flow on a link do not follow any fixed predefined pattern. TDM में फिक्स पैटर्न आता है, हर सेम स्लॉट जो है उस होस्ट को मिलता है जिसको वो एलोकेट हुआ है। बट इन केस ऑफ स्टैटिस्टिकल मल्टीप्लेक्सिंग और पैकेट स्विच नेटवर्क, same slot is not followed. Any available slot, you can say that any link or your pattern है, जो fixed pattern or predefined pattern is not followed in statistical multiplexing. And packet switch networks basically from different sources flow on a link, and they do not follow any pattern. So this is what we call statistical multiplexing.
सर ये जो स्टैटिस्टिकल मल्टीप्लेक्सिंग है ये फिर फ्रीक्वेंसी के साथ इंटरमैच
नहीं
कर
नहीं,
रही है ना?
नो 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 नो, फ्रीक्वेंसी से इसका कोई ताल्लुक नहीं है। देखें, इसका ताल्लुक, इट इज रिलेटेड टू टीडीएम। टीडीएम में फर्क यह है कि टीडीएम में आप स्लॉट, हर होस्ट को स्लॉट असाइन कर देते हैं, ठीक है,
यस।
और वो हर जब उसकी बारी आती है तो उसको वो स्लॉट मिलता है। अगर उसने ट्रांसमिट करना है तो वो ट्रांसमिट कर दे, अगर नहीं करना तो वो स्लॉट आइडल चला जाता है, क्योंकि दैट स्लॉट इज रिजर्व फॉर दैट होस्ट। अब स्टैटिस्टिकल मल्टीप्लेक्सिंग में क्या होता है कि फिक्स स्लॉट नहीं है, प्री डिफाइंड पैटर्न नहीं है, जो भी स्लॉट अवेलेबल होता है आप यूं समझ लें वो होस्ट को ऑफर किया जाता है, अगर नहीं है तो वही स्लॉट नेक्स्ट होस्ट को ऑफर कर दिया जाता है,
ठीक,
राइट? तो
यस।
इसका फ्रीक्वेंसी इससे कोई ताल्लुक नहीं है एफडीएम से। डोंट एवर ट्राई टू कंपेयर इट विद फ्रीक्वेंसी। ओके जी, now let's look at the question, this question. Suppose that users are sharing a 2 Mbps link. Users are sharing a 2 Mbps link. And also suppose that each user is transmitting continuously at 1 Mbps when transmitting, but each user transmit only 20% of the time. Now the question is this: when circuit switching is used, how many users can be supported? पहले तो क्वेश्चन ये है कि अगर हम सर्किट स्विचिंग यूज करें तो कितने यूजर सपोर्ट हो सकते हैं। Second part is this question is that packet switching is used. Now assume that in second part packet switching is used. Now, why there will be essentially no queuing delay before link if two or fewer users transmit at the same time? Why there will be queuing if three users transmit at the same time? Very logical, very systematic. Please think on it. You have 2 to 3 minutes, around 3 to 4 minutes for it. Okay, Ji. Anyone having a possible answer? Part A.
सर 2 यूज़र होंगे
राइट,
क्योंकि
जी बिल्कुल 2 यूजर्स होंगे। ठीक है, पार्ट बी।
और सर इसमें क्यू डिले आएगा क्योंकि जब 3 यूज़र हो जाएंगे तो सर वो टोटल कैपेसिटी लिंक की जो है 2 मेगाबिट पर सेकंड है। तो अगर 3 यूज़र होंगे तो ईच यूज़र 1 एमबी पर सेकंड ट्रांसमिट करना चाहेगा, तो जिसकी वजह से क्यू डिले होगा।
ओके, सो ओके जी, यू आर राइट, यू आर राइट। हैव अ लुक एट दिस आंसर। If you have any question, you are welcome. Very logical. Okay, ji, is it okay to everyone?
Yes, sir.
Okay, ji. And then next question is that advantages of circuit switch network over a packet switch network. And then TDM have over FDM in circuit switch network. Okay, so I mean, if you recall, you will find out the advantages. But again, uh, circuit switch network can guarantee certain amount of end-to-end bandwidth for a duration of call, right? So this is the benefit of circuit switch network. Packet switch network, as I told you that today's internet is also a packet switch network. There are no guarantees for end-to-end guarantees for bandwidth. And FDM requires sophisticated hardware to shift signal into appropriate frequency bands. That is the disadvantage of FDM in comparison to TDM. TDM is simpler. Is it okay, Ji? If you want to ask question, welcome.
सर जो सर्किट स्विचिंग होती है वो इंटरनेट में भी यूज़ करते हैं?
Not exactly same, मगर होती है. There is one standard ATM, asynchronous transfer mode. But there are some islands of that circuit switch networks. Predominantly, it is a packet switch network.
ओके सर।
Okay, Ji, we'll take a break here, and then after break, we'll talk about internet structure. So let's have a 15 minutes break, and after 15 minutes, we'll continue. Okay, Ji.
ओके सर।
Is everyone here? 15 minutes past. So, am I audible to everyone?
Yes, sir.
Okay, ji, let me share the slides again and let's start again. Okay, ji, can you see the slides?
जी सर.
Okay, so let's talk about internet structure. Now, it's a, as I told you in last class too, it's a network of networks. So we'll talk about its structure. So basically,
Excuse me,
recall that G.
अस्सलाम वालेकुम सर, मैंने क्लास थोड़ी ज्वाइन लेट की थी तो मेरी अटेंडेंस नहीं हुई और इस तरफ मेरी तरफ मौसम ख़राब है, लाइट का भी इशू बना हुआ है तो मोबाइल की चार्जिंग ख़त्म हो जाएगी अगर आप मेरी अटेंडेंस पहले ले लें तो.
मैसेज कर दें बेटा. I'll look into it how long you were present in the class. Message
ओके
कर.
सर.
Okay, so please, those who came late, don't interrupt. I will ask at the end of the class who came late or mark the attendance again. Okay, so basically, if you recall that we studied that we have internet service providers and there can be residential, enterprise, ISPs, right? Company, universities, ISPs. Now, access ISPs, which we are calling them as, in turn must be interconnected. Those access ISPs to which your residential internet, company, university are connected. So basically, they must be interconnected to each other so that all those ISPs, or simply you can say that all ISPs must be connected to each other so that they can send packets, host can packets to each other. So that as a consequently, your network of networks is very complex. And its evolution basically is driven by economics because, ISPs, they charge for, transmitting the packets. And also there are certain country policies are also there. For example, one country may not allow any packets from some other country. So there are some national policies too. So therefore, we will look at a structure, stepwise approach to find out that how internet looks like, right? Ji? So let's have a look on internet structure. So look at this, access nets. So millions of access ISPs in today's internet, millions of ISPs in today's internet. So these are, we call it as access ISPs or access networks are there. Access networks, recall access networks which we studied in last class. So there are millions of ISPs which are connected these access networks and we call them as access networks. Now the question is how to connect them together. Can we have a connection of, if, because if you want to send a packet from one access network to other access network, they must be connected to each other. So if we try to connect them with each other, so it means that each access network which will have a connection to every other access network. Is it like this? If they want to transmit packet to each other, so each access network should have a connection to every other access network. G, do you agree?
जी सर.
But look at this. It should be like this. For example, this access network should be connected like this. But it will take, look at this, every access network. So it will take, it will not scale. It will be not possible to have a connection to of one access network to every other access network. Means that it will take order of n scarce connections. For example, if you have millions of million ka square, n square means if you have n access networks, the order of n square. So this is something a problem. So we cannot connect each access network to every other access network to transfer packets. It will not scale, it will not converge. You can think like this, it requires order of n square connections. So which is not possible to have such huge number of connections to, right? So what to do then? How to connect them together, these millions of access ISPs? So now let's move to the next. So option is this, that let's connect each access ISP. These access nets, access ISPs are there actually. So to one global transit ISP, एक global ISP हम बना लेते हैं, and then that global ISP के through access networks को connect कर देते हैं, and they should have a agreement, economic agreement, that they will pay to each other. Look at this now. This is a global ISP. Global ISP, and each access network is having a connection to that global transit ISP, one transit ISP, and then through this transit ISP, the communication is done. So this is more feasible. If you compare it with the previous solution, this is more feasible, right? Right, Ji?
Yes, sir.
Yes,
But
sir, right.
practically speaking, one global ISP is not it's not possible, in fact, because if there is a one global ISP, they will be the only entity to earning money. So naturally there will be competitors. So practically speaking, we have list of international ISPs, big ISPs. Rather than a one ISP, there are competitors: ISP A, ISP B, ISP C, etc. And each access networks, different access networks too, will be having connection to these global ISPs, different global ISPs. There will be different, instead of one ISP, there will be multiple ISPs, big ISPs, global ISPs, you can think, right? And they will have a connection to each other through IXP. Look at this. These are IXPs. So naturally, because access networks want to connect to any other access network in any part of the world, so therefore these global ISPs, these big ISPs, they should be connected to each other, and they are connected through IXPs. IXP is an internet exchange point, and it is basically you can think like a building with its own switches. Switches means packet routers. Router is a packet switch. So this is how you can have IXPs. So this is a kind of structure of internet. Now, there may be a peering link. Suppose that there traffic between ISP and ISPs A and C is, a lot of traffic is going on, so they can have a direct link. This link is known as peering link. There can be a peering link. This is also ISP B or ISP C. There may be, instead of IXP, they can have a direct link, peering link, right? So then we have regional ISPs, global ISPs के साथ we can also have another class of ISPs, regional ISPs, country specific ISPs, and in this ways ISPs. And above them there is another thing, which is we call them as CDNs, content provider networks. Content provider, what are content provider networks? Content provider networks like Google or Microsoft, so may run their own networks. They, in addition to ISPs, these content provider networks, they run their own networks to bring services and content close to end users. For example, Google's YouTube. For example, let's say if Google has a YouTube servers only in USA, so naturally from Pakistan it takes a long time to access to USA servers. So therefore, what Google does, Google basically bring users their servers to different locations of the world, so that users of that location, they can get their content quickly. So if they are closer to the certain region, so that content will be quickly accessed. So these are known as content provider networks, right? Ji? So this is what we have. And now I'll show you the structure of network in another way. So this is internet structure. Different levels of ISPs, and we call these different level of ISPs the tiers of ISPs, tier of ISPs. So this is a big ISP, tier 1 ISP. The global ISP, you can think Google is also a global entity, content provider network. And then we have IXPs. IXPs ke through we connected to regional ISPs, and then regional ISPs are connected to access ISP. There is no hard and fast rule that access ISPs should only be connected through regional ISPs. Tier 1 ISPs can also have a connection, direct connections to access ISP. So this is a kind of a structure of a network, internet structure, through which you can have a connection. Have a look on it. If you have any question, you are welcome. I'll pause here for 1 minute, and you can review. And if you have any question, you are welcome.
सर जो हम VPN यूज़ करते हैं जब कभी कोई सर्विस नहीं चल रही होती जैसे फेसबुक वगैरह, तो वो भी जो है ये CPN ही होता है?
VPN और चीज़ है बेटा। VPN तो आपकी आइडेंटिटी को हाइड कर लेता है, इसका इससे कोई ताल्लुक नहीं है। ठीक है, वो ये चीज़ हाइड कर लेता है कि आप कहाँ से वो कर रहे हैं। उसका इस कंटेंट प्रोवाइडर नेटवर्क से कोई ताल्लुक नहीं है। दैट इज समथिंग एल्स।
सर हम ISPs पढ़ रहे हैं ना, इंटरनेट सर्विस प्रोवाइडर्स, तो वो ये गूगल कैसे एक इंटरनेट सर्विस प्रोवाइडर है?
बेटा मैंने आपको, हम ISP नहीं पढ़े, हम इंटरनेट स्ट्रक्चर पढ़ रहे हैं, पहली बात।
सही
अब इंटरनेट स्ट्रक्चर के अंदर हमने देखना है कि इंटरनेट के अंदर जो है ना, गूगल जो है कंटेंट प्रोवाइडर है, वो ISP नहीं है।
जी सर, कंटेंट प्रोवाइडर है, वो तो बात ठीक है सर।
हाँ, तो कंटेंट प्रोवाइडर का इतना ह्यूज नेटवर्क है कि हम उसको इग्नोर नहीं कर सकते इंटरनेट स्ट्रक्चर से।
सही होगा, मतलब वो कंटेंट प्रोवाइडर भी है और साथ उसका एक अलग स्ट्रक्चर भी है अपना ISP का।
जी बिल्कुल ऐसे ही है, क्योंकि उसने ना, गूगल ने ये किया हुआ है कि डिफरेंट रीजन्स में अपने सर्वर्स रखे हुए हैं और उन्हें आपस में कनेक्ट किया हुआ है। फॉर एग्जांपल पाकिस्तान के लिए मे भी सिंगापुर में सर्वर्स हों, यूरोप के लिए उसने सेपरेट सर्वर्स रखे हुए हैं ताकि क्विकली एक्सेस हो जाए उसका कंटेंट। गूगल इज अ कमर्शियल कंपनी, दे वांट टू अर्न मनी, so if their content is not accessible in a fast way, so naturally they will lose money. So that's why they have their own network, content provider network we call it as, so at a different locations of the world. That's why it becomes a part of internet structure.
सर मतलब जब भी हम कोई सर्च करते हैं गूगल पे तो वो सिंगापुर के सर्वर पर जाती है और फिर वहां से हमारे पास डाटा आता है वापस।
इसके लिए ट्रेस राउट का एक यूटिलिटी होती है, उससे आपको पता लग जाएगा। तो गूगल ने करीब सर्वर्स रखे हुए हैं, बाज कंट्रीज के अंदर रखे हुए हैं।
सही होगा सर।
इंडिया के अंदर सर्वर्स रखे हुए हैं, जो बड़ी कंट्रीज हैं, यहाँ पे आबादी बहुत ज्यादा है। अब हर कंट्री में नहीं रखे हुए, so because we have to look into the exact architecture, but they don't have, for a small country they don't have, they may be having a network servers for set of countries closer to them.
सही होगा सर, सही होगा, अंडरस्टैंड।
Okay ji, if you don't have any question, let's move to next slide. So this is just a tier 1 network of US company Sprint. So they have a, just for your understanding, so you can have a look on from book. I'll not go into more details. They have point of presence POPs. Okay, now let's move to next topic, and this is basically performance and loss, delay, and throughput. So this is in fact the last topic. Next time we will talk about further details of it, of today's lecture. Okay ji. Now the question is this, that how do packet loss and delay occurs? This is a question which we are having, that how we have a packet loss or delay. So you recall we have a packet queue in router buffers. There are buffers and packet queues may develop in packet switching. And when you have a packet queue, they have to wait for their turn. So it's not possible that they can quickly this. And what will happen that if arrival rate to link exceeds arrival rate, not always, it does not always exceeds, because traffic is bursty in nature. So therefore it is sometimes it exceeds, sometimes it does not exceed. So let's say that if temporarily receives, so what will happen, then it will be placed in buffers, and buffers capacity full, if fills up, then there will be a packet loss, then there will be a packet loss, right? Okay ji. So for instance here, that packet being transmitted, transmission delay L by R, and then these are the packets in buffers. This is the blue packet is being transmitted, and the remaining packets are in buffers. A queuing delay will be there, right? And this white space is something free available buffers. These white space is a free available buffers. So if their free space is available, then packets will be placed in these buffers or queue. Sometimes we call it as a queue. And if there is no space available in buffer, then arriving packet will be dropped or lost. It will be lost or discarded. You can say whatever you call it. So this is how things are done. Have a look on it. If you have any question, you are welcome.
सर अक्सर जगहों में राउटर की जगह स्विचेस भी यूज़ होते हैं, तो उसमें भी ये फिनोमेना वर्क करता है या नहीं?
बेटा स्विचेस जो यूज होते हैं ना, वो आपके यूज होते हैं लैन के अंदर, लोकल एरिया नेटवर्क के अंदर, विद इन अ सिंगल नेटवर्क. ओके,
Okay, sir.
switches are used in within a single network. Like in our university is a single network, so we have a switches, set of switches. और जब आप दो डिफरेंट नेटवर्क्स को कनेक्ट करते हैं आपस में, you cannot use a switch, you need a router, right? When you connect two different networks like UT Tesla and UT Lahore, if you want to connect them together, you need a router. So internet basically is a collection of networks, collection of different networks. So these networks are connected to each other with the help of router. Switch will not work. Switch is used within a single inside the organization, right? So whatever we are studying here is applicable only to routers. In some loose sense, it can be applicable to switches, but in switches, delay is not like this. Okay.
Okay, sir.
Yeah. So this, keep this thing in mind. Switches को आगे हम पढ़ेंगे कहीं पे. Okay, ji. Okay, let's move to, now we'll talk about these delays. So there are four sources of delays. So we'll talk about them one by one. One delay you have already studied. That was, what was that delay जो आपने पढ़ा है?
Sir, transmission delay.
The transmission delay, you have already studied transmission delay. Now we'll talk about the other delays, which are propagation delays and queuing delay and nodal processing delay. So these are the four delays, and overall four delays are processing delay, queuing delay, transmission delay and propagation delay. And when we add up them together, it is known as nodal delay. We call it as nodal delay. So nodal delay is a sum of processing delay, queuing delay, transmission delay and propagation delay, right? This is what we are having. So we'll talk about them one by one. So first of all, processing delay. Now there is a time is taken for processing. So when packets arrives at a router, so it takes time to process it, because there are a lot of things which are being done. For instance, bit errors. The first thing which is done is that whether your packet is without errors or not, right? So there are error detection methods. We'll study them later on in this next lectures somewhere, but again it checks the packet for bit errors. because if there are errors in the packet, it will not be forwarded. It should, uh, error correction method should be employed. So therefore, bit error is an integral part of every router. The bit errors detection is done. So naturally, it takes time to check for bit errors. So the time which it takes to check bit errors plus determination of output link is known as processing delay. Processing delay, nodal processing delay, processing delay. Simply processing delay, you can call it as. So processing delay is there, and it is typically less than some milliseconds. Then comes queuing delay. I hope you have studied it. That time waiting, we have studied it a little while ago also at many instances. Uh, Time waiting for a output link for transmission. You know, in last slide we said that queue can occur in a buffer of a router if arrival rate is greater than the transmission rate. So therefore, time is required to for waiting period is there for output link for transmission, and it depends upon the congestion level. There is no fixed time we can find out for it. It is quite possible that at a certain time a router is queue is full, so it will take a lot of time for more time to be transmitted to the output link. But if router not congested, so quickly it can be transmitted on an output link. So this is something which is there. So it is variable. It is in variables. Time delay is variable. So this is what we call queuing delay. Okay, ji. Then we have next is transmission delay. So you already know about transmission delay, so I'll not talk about it. It is L by R. And the last one is known as propagation delay. This is known as propagation delay. And propagation delay depends upon D and S. What is D? D is a length of a physical link. And this length is in physical, it is not hop. So D is a length of link in meters, kilometers, whatever it is. And S is a propagation speed in medium. Typical speed in a medium is 2 × 10⁸ meter per second. So propagation delay, we call it as D by S. So keep this in mind that transmission delay is not equal to propagation delay. They are two different things, right? So these are the four delays which we are having: processing delay, nodal processing delay, transmission delay, queuing delay, propagation delay. Right, Ji?
Yes, sir.
Okay, if you have any question, you are welcome. So if you know no question, then I will move to next slide. So, Ji, please go ahead.
सर ये आपने यहाँ पर जो इक्वेशन एक छोटी सी लिखी है कि नोडल डिले जो है वो प्रोपोगेशन डिले प्लस क्यू डिले प्लस ट्रांसमिशन डिले प्लस फिर प्रोपोगेशन, तो दो दफा ही क्यों है सर?
दो दफा नहीं, थोड़ा सा कंफ्यूजिंग हो गया है, ये टोटल डिले है।
जी सर।
हाँ, ये थोड़ा सा
टोटल डिले में अच्छा वो उसकी जगह नोडल आ जाएगा सर जो लिखा हुआ है?
आप इसको टोटल डिले ही समझेंगे, टोटल है या पूरे नोड का तो नहीं होगा, टोटल डिलेज जो आते हैं इसको यूँ समझ लें, या इसको
अच्छा।
खाली प्रोसेसिंग डिले समझ लें। इसको जो है ना नोडल को ना समझें, इसको प्रोसेसिंग डिले समझें। ये स्लाइड में एरर है, सिंपली प्रोसेसिंग डिले कह लें।
सही हो गया सर। अच्छा ये प्रोसेसिंग डिले होगा।
The concept is this is D node and D process are different things.
अच्छा सही।
So at the end I will say that propagation delay is not equal to transmission delay. They are two different entities. Look at this. Their relationship is different. So propagation delay depends upon length of the physical medium and propagation speed. But transmission delay depends upon the size of a packet and link transmission rate in BPS. Okay. Now, in order to strengthen the concept, we'll take some analogy. So let's say that we have cars, 10 cars, or we have a highway or motorway. In our context, we call it as a motorway. Motorway has tool booths. Let's say tool booths are there, toll or tool, whatever you say. In Urdu, we call it as tool. In English, we call it as toll. Toll booths. So this is a toll booth. This is also a toll booth, and the distance between them is 100 kilometer. And we have a 10 car caravan. 10 car caravan. So let's say that cars are propagating at a speed of 100 kilometers per hour. Cars are propagating, moving at a 100 kilometer per hour. And toll booth takes 12 seconds to service a car. To service car. 12 seconds to service a car. So in our analogy, consider cars as bits and caravan as packet. So 10 cars, a 10-bit packet, right? Now the question is this: how long until caravan is lined up before second toll booth? How long it will take until caravan is lined up before second toll booth? Can you calculate? Cars are propagating at 100 km per hour and 12 seconds is taken to service a car. So consider it as bit transmission time. Now can you calculate?
Sir, 1 hour and 2 minutes.
Okay, ji. Okay, ji. So time to push entire caravan through toll booth. Recall that it takes 12 seconds. So 10 car caravan तो 12 into 10. ठीक है जी? Is it okay? यहाँ तक ठीक है?
जी सर, जी सर.
Okay. So total time is 100 km per hour. Right? For a last car to propagate from first to second toll booth is 1 hour. ऐसे ही है?
बिल्कुल सर.
And then total time is 1 hour and 2 minutes. 62
Yes, sir.
minutes. Total is 62 minutes. Does it make sense? क्योंकि कार ने जो टाइम ईच कार को लग रहा है वो ये 12 सेकंड्स का यहाँ पे लग रहा है. तो once it is out from here, it will move at 100 km per hour. Right? So this is what we will have. Time for a last car to propagate from first to second toll booth. ठीक हो गया जी? किसी को कोई क्वेश्चन है तो you can ask. So again, car is a bit and a caravan of cars is a packet. Have a look on it. I'll give you around 1 minute because it is important to understand this analogy because it is very similar to packets.
Excuse me, sir.
जी.
सर ये सेकंड पॉइंट क्लियर कर दे रहे हैं, ये 62 मिनट का है.
कौन सा पॉइंट बेटा?
ये
ऊंचा बोले, जरा ऊंचा बोले.
सर ये जो सेकंड पॉइंट आपने बोला है, ये टाइम फॉर लास्ट कार टू प्रोपोगेट फ्रॉम फर्स्ट.
देखिए ना, पहली कार, अच्छा देखिए पहली कार यहाँ पे है तो इसको 12 सेकंड लगे. ठीक है, 12 सेकंड के बाद ये 100 किलोमीटर आवर पे जाएगी. तो यहाँ पे पहुंच जाएगी, 1 आवर में पहुंच जाएगी ना, 1 आवर और 12 सेकंड्स में, ऐसे ही है।
यस सर।
एक कार, फिर अगली कार आएगी उसके फौरन बाद, उसको भी 12 सेकंड लगेंगे,
ठीक हो गया सर आगे।
उसके बाद अगली को भी 12, तो टोटल कितने सेकंड्स लगेंगे 10 कार्स को, 120 सेकंड। तो यहाँ पे तो सेम स्पीड है ना, सब 100 पे जा रही हैं, तो यही डिले आएगा ना इनका 120 सेकंड्स लाइन अप करने से पहले। ये तो 100 पे यहाँ से, वंस दे आर आउट फ्रॉम फर्स्ट टोल बूथ, ऑल कार्स विल बी मूविंग one after another at the same speed, 100 km per hour. So you can say that 1 hour will be taken for each car to move from this point to this point, but the time is taken here. Each car is using 12 seconds to process, so total 10 cars, 12 multiplied by 10, 120 seconds will be required. Once they are out from them, they will reach here. The first car which is processed after 12 seconds will come line up first, and then second, then third, and so on, 10th car. So total is 62 minutes.
सर वैसे एक बात है
जी, गो अहेड
सर, जिस तरह मसलन अगर हम देखें 10 कार्स है ना, तो पहली कार को प्रोसेस होने में 12 सेकंड्स लग गए, ठीक है, तो जो उससे पिछली कार है उसको भी प्रोसेस होने में 12 सेकंड लगे, लेकिन उसने 12 सेकंड वेट भी तो किया, तो 24
टोटल
सेकंड
इसीलिए
नहीं।
12 मल्टीप्लाई बाय 10 कर रहे हैं ना, खाली एक 12 तो नहीं ले रहे, ये 12 सेकंड के बाद निकल गई तो 12 प्लस 12
24।
हाँ, तो इसी तरह 12 को प्लस 12 प्लस 12 प्लस प्लस करके 10 मल्टीप्लाई बाय 10 का मतलब है 12 को 10 टाइम्स ऐड कर दें।
सर वो तो ठीक है, 10 टाइम्स ईच कार को प्रोसेस हो रहा है, लेकिन जो वेटिंग टाइम है हम वो इंक्लूड नहीं कर रहे।
बेटा वेटिंग टाइम, टोटल वेटिंग टाइम इस तरह इंक्लूड हो रहा है ना कि 10 कार्स को निकलने के लिए 120 सेकंड्स ही लगेंगे ना। तो एक कार को अगर 12 सेकंड्स लगते हैं तो 10 कार्स को 120 सेकंड्स नहीं
लगेंगे सर, बिल्कुल लगेंगे, लेकिन मैं ये कहना चाह रहा हूँ कि सर वो जो पहली कार को प्रोसेस होने में 12 सेकंड लगे, वो क्यों नहीं ऐड हो रहे सेकंड कार को प्रोसेस होने के उसमें? मेरा ख्याल से सर ये ऐड होके कुछ ज्यादा बनेगा शायद।
नहीं ऐसा
वेटिंग टाइम सर अगर
नहीं,
डालें
ऐसा
तो।
नहीं है बेटा, ऐसा नहीं है।
चलें सर, ठीक
अब
है
ये
सर।
सिंपल मैथमेटिक्स है, ऐसा नहीं है।
सही होगा सर।
आप जो है अब आप इसके लिए एक्सपेरिमेंट कर लें, बस यही है मैं आप कह सकता हूँ, सिमुलेशन कर लें कोई, इट्स नॉट लाइक दिस। आप ऐड अप देखें 12 सेकंड्स के बाद ये कार निकल के यहाँ आ गई, ये पहले ये है कि ये स्टेशनरी है कार्स, ठीक है, इनिशियली ये स्टेशनरी है 10 कार्स। अब 12 सेकंड के बाद ये कार इधर हाईवे पे आ गई, सपोज करें फॉर द टाइम बिंग।
ठीक हो गया
अब
सर।
उसके बाद अगली कार आई, उसको 12 प्लस 12, उसको नेक्स्ट कार को एक्चुअली कितने लग रहे हैं
24 सेकंड सर।
24 सेकंड्स लग रहे हैं ना
जी सर।
तो उससे नेक्स्ट कार को 36
हो गया, 36
तो
हो
इसलिए
गया।
12 प्लस 12 प्लस ये प्लस हो रहे हैं ना 10 टाइम्स।
जी सर।
तो इसलिए इस 120 सेकंड्स ही लगेंगे, तो इसमें वेट टाइम शामिल है, यू कैन थिंक लाइक दिस, क्योंकि पहली कार को अगर 12 लग रहे हैं तो दूसरी कार को कितने लग रहे हैं
24 सर।
24 सेकंड्स लग रहे हैं ना,
और थर्ड कार को सर 36 लगेंगे, तो सर इन सबको प्लस भी करें तो ज्यादा बनता है सर। 12 प्लस 24 प्लस
देखो
36
बात
प्लस
सुने,
22।
नहीं इस तरह नहीं है ना बच्चे, इस तरह नहीं है, चले आप सिमुलेशंस कर लीजिएगा।
अरे सर ठीक हो गया सर।
क्योंकि ये इट्स नॉट लाइक दिस कि चलें आखिरी कार को तो बात किया ना कि आखिरी कार को टोटल टाइम तो पैरेलल, चलें अच्छा छोड़ें इसको, ये बहुत लंबी डिस्कशन हो गई। ओके, नाउ सपोज दैट कार्स आर प्रोपगेटिंग एट 1000 किलोमीटर पर आवर। अब 100 किलोमीटर से क्या हो गया है, स्पीड क्या हो गई है 1000 किलोमीटर पर आवर हो गई है। एंड सपोज दैट बोथ टोल्स टेक्स 1 मिनट टू सर्विस अ कार। टोल बूथ जो है वो अब क्या कर रहा है 1 मिनट ले रहा है, पहले कितना ले रहा था
सर 12 सेकंड।
अब टोल बूथ ने क्या किया, अब स्पीड गाड़ी की ज्यादा हो गई, 100 से 1000 हो गई,
सही हो गया सर।
लेकिन टोल बूथ इज टेकिंग instead of 12 minutes it is taking
1 मिनट
12 seconds, instead of 12 it is taking 1 minute।
जी सर।
so
600 सेकंड हो जाएंगे सर।
will a car arrive to second booth booth before all cars service at first booth? तो आंसर इज यस, क्योंकि पहली कार जो है 1 मिनट बाद जब सर्विस हो जाएगी 1000 से स्पीड से चलेगी तो वो पहले पहुंच जाएगी आखिरी के सर्विस होने से पहले. आफ्टर 7 minutes first car arrives at second booth. So 3 cars are still at first booth. So this is what will happen. Right, see? So think about it, it will happen like this. Now because it is taking more time, so first car will after 1 minute when it will go through the toll booth, it will propagate at 1000 kilometers per hour. So it will arrive, you can calculate a time, and then the last car, 3 cars will still be at the first toll booth, and the 7 cars will arrive at second toll booth. So this is something which you need to understand. So toll booth is like a router. Toll booth is like a router. So it means that now here router is taking more time to process. So when router takes more time to process, it is quite possible that the sum of the bits of the packet arrives at the other router before the last bit is emitted from the first router, the previous router. But again, because it is a packet switch network, it is a store and forward concept. The second router has to wait for all the bits before it processes the packet. Second router will have to wait for all the bits before it can process the packet. Or you can say that second toll booth will not emit the cars onto this link until all calls arrives at this toll booth. So you have to keep this thing in mind. So it depends upon what? It depends upon the propagation speed, this speed, and also the time it is taken at a router, right? So these are the two factors which are involved in transmission of packets. So now let's revisit queuing delay again. Have a look on it. Now we are, if you recall, we have studied transmission delay as L by R, right? Now here we are adding one additional parameter, which is A. What is A? A is the average packet arrival rate. A is the average packet arrival rate. Again, R is same, which we have already studied, length, bandwidth, and L is the packet length, bits, packet length, which is in terms of bits. Now here A is added because average packet arrival rate, because packet arrival rate is bursty in nature, so therefore A is added to add up the arrival rate of the average arrival rate of the packet. So now if you look at this, if your LA by R is approximately 0, means average practically it's not 100% equal to 0. We are only saying that approximately equals to 0 means it is small. This delay is small, that your average packet arrival rate is small. L by R का तो आपको पता ही है तो. So if it is small, then you have structure like this. So this is a traffic intensity. You say traffic intensity is LA by R, and we are calling it as average queuing delay is like this. So if LA by R is 0 or near to 0, so average queuing delay is small. So look at this line, straight line. And if LA by R is 1, average queuing delay becomes large. Look at this. ये जो ऊपर line जा रही है. Right? And if LA by R is greater than 1, so more work arriving is, so means more work means arriving is more than it can be serviced. So average delay can become infinite. So this is a dangerous thing. We want to reduce this LA by R. If it goes greater than 1, it can go to infinite. Infinite means large delay can occur here. So it all depends upon the traffic intensity. L is a link bandwidth, R is a L by R is the transmission delay, but when we say A by R, we call it as traffic intensity. So it all depends upon this A factor, because this is the average arrival rate. L can be variable, but it's not very variable. Packet size can change, but R is constant. Link bandwidth is constant. So this is something which we have, LA by R. Okay, G. Any questions? So this is like this. LA by R is equals to 0 means, look at this. Okay, your highway is only having a single car. And LA by R greater than 1 or maybe equals to 1. Look at this. Highway is having a lot of cars. Just for analogy purpose. Okay, Ji. Any question? Is it okay to everyone?
Yes, sir.
Okay, let's move further. Next slide. So there is a what do real internet and delay loss look like? So there is a Windows mein ek command prompt pe aap jaake trace route. Trace route is a utility program which basically measures the delay from source to router along end-to-end internet path towards destination I. So basically what trace route does, look at this. So it sends a probe packets, 3 packets that will reach a router I. पहले इस router पे जाएगा, फिर इस router पे, and it will time to live field is there, TTL field, how long the packet can live in the internet. Then router I will return the packets to the sender, and sender measures the time interval between transmission and reply. So you can use this utility practically to find out the delay between source and destination. So it will tell you. So practically try to do this at So in this way, 3 probe packets are sent to each router and time delay is calculated. Then this is an example, 3 delay measurements, sending and receiving and total, right? So trace route, for example, GIA.cmas to eurocom.fr. So this is a trace route example. So try this at home. Okay, next is packet loss. So queue and buffer are 2 interchangeable entities, right? So you know that this buffer or queue is having a finite capacity, right? This queue and buffer is having a finite capacity. So therefore, packet arriving to full queue will be dropped or lost. We call it as lost. Now, how to recover from this? So the lost packet may be retransmitted by previous nodes or by source and system or not at all. So this is what we call packet loss. When packet loss will occur? When your queue is full and packet arrives, then there is no space in a buffer, so that packet will be lost. So this is known as packet loss. Now let's move to next slide, throughput. This is another important parameter which you need to understand. What is throughput? Throughput is a rate. Rate means bits per unit time at which bits are being sent from source to or sender to receiver. Now you need to understand that different links have different capacities. Different links have different capacities. So as a result, we have 2 types of throughputs, instantaneous throughputs and average throughput. Instantaneous means that the rate at a given point in time. An average is a rate over a longer period of time, that you sum up them instantaneous throughputs and you get an average throughput. So look at this. This is a server and this is a client, a system, and this server is having a link capacity of RS bits per second to this router. Server to router is RS bits per second, and this router to this system is RC bits per second. So different link capacities. So server is sending a file of F bits to the client. We are assuming that server is sending a file of F bits to the client. So what will happen? Look at this now. Suppose that these link capacities are analogous to a pipe that can carry a fluid at a rate. So this RS is having a this capacity pipe, and this pipe can carry RC fluid bits per second. Call it as fluid. So what will happen? So this is more wide. This pipe is more wide. It can carry more bits, right? And this is not. This volume is less. So if now let's assume that RS is less than RC. RS is less than RC. Look at this. Here RS is smaller in volume and RC is greater. So we are saying RS is less than RC. So what is the average end-to-end throughput? क्या होगी average? दोनों में क्या होगा? यहाँ पे क्या सिनेरियो है कि अब RS is greater than RC. So what is the average end-to-end throughput?
सर जो स्मॉल होगी वो वही थ्रूपुट होगी.
दोनों केसेस में कोई फर्क होगा?
नो सर, कोई फर्क नहीं होगा.
So yes. So but anyways, अगर आप एवरेज थ्रूपुट बढ़ाना चाहते हैं तो फिर इस RS को बढ़ाना पड़ेगा और यहाँ पे इस RC को बढ़ाना पड़ेगा. So constraint is link. What is the constraint for end-to-end throughput is link throughput. For example, here this link through R is small, so it is a constraint. And here RC is small. This is a constraint, right? So link on end-to-end path constraints end-to-end throughput. Link on end-to-end path like RC here or RS here, it constrains the end-to-end throughput. Okay, Ji, is it okay? किसी को क्वेश्चन है? वेलकम.
नो सर, कोई क्वेश्चन नहीं है.
Okay, let's move to the next slide. So this is a another scenario in which there is a network, and consider it as again this link throughput R, और इनके individual क्या हैं? There are 10 connections और हर एक की क्या है? Throughput RS है. RS is smaller, big R is greater, capital R is there. So here 10 connections are fairly sharing the backbone bottle. So backbone network, right? Now here basically the thing is that per connection is end-to-end throughput क्या है? Per connection RS, ठीक है? और यहाँ पे R जो है वो शेयर हो रही है कितने के दौरान? जो कैपिटल R है शेयर्ड बिटवीन 10 यूजर्स. तो क्या हो जाएगा? R/10. एक इंडिविजुअल के लिए पर कनेक्शन लेंगे तो R/10 हो जाएगा यहाँ पे, और ये जो है RC. तो पर कनेक्शन एंड-टू-एंड थ्रूपुट क्या है? इधर से लेंगे RS, R/10 एंड RC. ऐसे ही है. और मिनिमम इन तीनों का मिनिमम जो है वो यूज होगा. अब जो भी वट एवर द मिनिमम है, इन तीनों का मिनिमम जो है वो यूज होगा पर कनेक्शन एंड-टू-एंड थ्रूपुट. ऐसे ही है ना लॉजिकली, जो मिनिमम होगा. Please focus on this. This is important. That there are three, link throughputs from here to here. Let's say this client has RS. अब ये because this capital R is shared between 10 users, so for each user you will have R/10, and this is RC. So whatever the minimum is, so this will be the throughput for that connection. In practice, practically speaking, the bottleneck is not this big R, because this is a company has a large bandwidth. Bottleneck is RS or RC. RS or RC is smaller. Okay ji, any question? If you have any question, welcome. Okay, I assume you don't have any question, so let's complete this completes today's lecture, but there are some review questions which we will cover, and after this I will close the class. Consider a packet from source to destination over a fixed route. तो कौन कौन से डिलेज आएंगे, which delays are constant and which are variable?
सर क्यू डिले वेरिएबल होगा।
और टोटल कौन कौन से कितने डिलेज थे अगर आपको याद हो?
सर 4 डिले हो गए।
4 डिलेज थे। and what were those? क्यूइंग डिले के अलावा 3 रह गए।
ट्रांसमिशन डिले, प्रोसेसिंग डिले एंड प्रोपोगेशन डिले।
Yes, right जी, so you are right. So this is a answer for it. The delays are processing delays, transmission delays, propagation delay, processing delay, right? And total is called nodal delay and queuing delay. So all are fixed except for queuing delay. Queuing delay क्यों है? क्योंकि we cannot, because internet traffic is bursty in nature, and as a result we cannot predict queuing delay. Okay, next question. So let's say we have a packet of 1000 bytes to propagate over a length of 2500 kilometer, and propagation speed is 2.5 into 10 raised power 8 meter per second, and transmission rate is 2 Mbps. So how long it will take a packet of length L to propagate over a length of distance D? Propagation speed S and transmission rate are Bps. Right? Does this delay depend upon packet length? And does this delay depend upon transmission rate? Please think on it.
सर स्क्रीन ही गायब हो गई है।
हाँ?
स्क्रीन सर नजर नहीं आ रही आपकी, वो शेयरिंग खत्म हो गई।
बाकियों को नजर आ रही है कि नहीं आ रही? कैन यू एनीवन गिव फीडबैक?
नो सर, आपकी
नहीं आ रही
शेयर
सर।
नहीं हो रही
जी
नहीं सर, नहीं
नहीं
नजर आ रही।
शेयर हो रही।
Okay, let me share again. Let me share again. Okay, ji, can you see the slide now?
Yes sir.
Okay जी, so it's not difficult. Propagation delay कैसे निकालेंगे? कौन सा फार्मूला है? याद है?
D by S.
D by S. So using D by S formula you can calculate 10 millisecond. It would be 10 millisecond. और D by S है, और ये जो आखिरी दो का आंसर है वो that is no. So next question is, suppose that host A wants to send a large file to host B. The path from host A to host B has 3 links. R1 500 Mbps है, R2 2 Mbps and R3 1 Mbps है. So assume that no traffic is part A को करते हैं. Assume that no traffic is in the network. What is the throughput of a file transfer? इसके लिए कोई कैलकुलेशन की जरूरत नहीं है. जी, you can find it out quickly.
So 500 kilobits per second.
Yeah, 500 minimum. तीनों का जो मिनिमम है वो क्या है, 500 है ना, क्योंकि R2
Yes, sir.
और so it would be 500 kbps. So next is I'll show you the answer. Suppose that file is 4 million bytes. Divide the file size by throughput. Roughly how long it will take to transfer to host B. Divide करके आप निकाल सकते हैं, मगर again L by R से 500 kbps, तो L by R 400 into ये 10 power 6 है, 400 million, sorry ये typo error है, 10 power 6 है, into 8 bits bytes थे, 8 bits divided by 500 into 10 power 6 bits per second. So it will take around 64 seconds. So third का आंसर जो है वो given है इसी तरह. Okay जी. So this completes today's lecture. And now at the end, if you have any question, you are welcome to ask. Okay जी. Any questions?
Excuse me, sir.
जी.
The second part repeat कर दो, नहीं समझ आई.
जी.
सर जो लास्ट स्लाइड पे पार्ट बी आपने किया वो रिपीट कर देंगे सर.
पार्ट बी मैं बताता हूँ, पहले क्वेश्चन पार्ट बी का मैं आप दोबारा दिखाता हूँ. Okay, can you see the slides? Slides नजर आ रही हैं आपको बेटा?
यस सर.
अब देखिए 4 मिलियन बाइट्स है ना, 5 आपका डाटा क्या है, 4 मिलियन बाइट्स का है, तो 4 मिलियन, मिलियन का मतलब 4 into 10 power 6 बाइट्स है, तो बिट्स में कितना होगा?
मल्टीप्लाई बाय 8 कर देंगे.
मल्टीप्लाई बाय 8 कर देंगे ना, तो L by R का फार्मूला लगाएंगे. R क्या है, अब R आपने निकालनी है, R क्या थी आपकी, ऊपर R क्या निकाली है, बैंडविड्थ क्या होगी? अभी पार्ट ए में क्या निकाला है आपने?
500.
जी
500.
500, तो L R जो है 500 होगी, तो अब 400, अब यहाँ पे देखें 400 into 10 power 6 into 8 बिट्स, और R की 500 थी, तो L by R के थ्रू 500 से आप डिवाइड कर देंगे इसको बिट्स पर सेकंड से, तो 64 सेकंड आ जाएगी.
ओके सर.
ठीक है, L by R से निकालेंगे और R आप 500 लेंगे किलो बिट्स. पार्ट सी आसान है कि R2 जो है अब आपकी रिड्यूस होगी 100 kbps से, तो R2 रिड्यूस भी हो जाए 100 kbps, तो अब आपकी क्या हो जाएगी, अगर R2 100 kbps हो जाए तो बैंडविड्थ क्या आएगी, थ्रूपुट क्या आएगी,
100 kbps ही आएगी.
100 kbps हो जाएगी. मिनिमम लेते हैं तो मिनिमम अब R2 हो जाएगी तो 100 kbps हो जाएगी, तो सेम फार्मूला लगा के आप कर सकते हैं.
ओके सर.
ठीक है जी.
Yes, sir.
Okay, at the end, those who came late, they can speak or tell me that, so that I can ask them that why they were late. 30 है? Is 30 present? No. 30 is absent. Let's mark him absent. 47. Is 47 present? So 47 is also absent. 96. Is 96 present? So 96 is also absent. Then we have 150. The 150 present है? तो absent. 153.
Yes, sir, present.
So G, what was the issue?
Yes, sir.
Why you came late and how long, how much late you were?
सर वो नेट इशू था, इधर मैं गाँव में हूँ तो अभी थोड़ी देर पहले वो सिग्नल ठीक हुआ है यहाँ।
चलो 176. 176 is absent. Then we have 177.
यस सर।
जी आपका क्या इशू था?
सर मैंने 8:45 में ज्वाइन की थी।
जी 8:35 पे था।
8:45।
चले okay. And then we have 201. 201 is present, so absent. Okay जी. Okay जी. So there are 1 2 3 4 5 6 absents. जी anyone else?
सर रोल नंबर 72 भी प्रेजेंट है, तो उनका माइक खराब है, तो वो कह रही है आपको बता दूं।
72?
यस सर।
Okay, I have marked our attendance. तो जिनने मैं एब्सेंट बोला उनमें से तो किसी का माइक का इश्यू नहीं है, तो ओके जी, ओके. So please study with the class. Very soon you will have quiz. So please study with the class. I have provided you chapter, So therefore study with the class. So if you don't have any questions, further questions, so we'll terminate the class now. ठीक है जी.
ओके सर।
ओके जी, अल्लाह हाफिज़.
अल्लाह हाफिज़।